Hey guys, welcome to this video. I will show you how to download and install the Raspberry Pi image. So to get started, go on deepcyclepower.com, select the software category, and here I added the Mega CNC Raspberry Pi image. It has a small cost added to it because I need to cover the download cost. I hosted the file on an Amazon S3 to have a fast download link and also reliable source to get the file. It's 2 gigabytes, and if people are downloading this multiple times, it adds to the cost to deliver this file properly. Having it on Google Drive or Dropbox, that will ban my account, unfortunately, on a lot of downloads. I had that in the past, and having it on Amazon is the best choice for now. So after you pay for this, you receive a link to download the file. Once you download the file, you need Raspberry Pi image writer. So it's a software that's like this. You install it on a Windows machine, then you choose the device you want to write to. Raspberry Pi4, and then go to use a custom image. This is the image. You're going to receive a zip file, unzip that, and you're going to get an image that you select. Then you choose the storage. You're going to need an SD card for your Raspberry Pi. Looks something like this. It needs to have at least 16 gigabytes. That's the minimum because I created the image on a 16 gigabytes SD card, and you install that into an SD card reader like so, this one, and then you choose the storage. It takes a while to write it, so until that's done, let me talk about the PCB that I've been working on for the past couple of days. It took me like 2 days to get this done. This is the second version actually, because the first version did not include everything I needed. I discussed with my colleague Mihai, that's working from time to time with me on the Megacell Charger, making new features and stuff like this. So we decided to go with this design. This board will be an accessory for the Megacell Charger Pro that will allow you to fully test an assembled battery. The battery can contain up to 16 cells in series, so it doesn't matter how many in parallel, but it can go with 16 in series because we have made it with 16 channels. This device right here will switch each channel and test that cell for capacity. It's not going to test all the cells at the same time. It's going to test them one at a time, store that capacity, and move to the next one until it finishes testing all the cells that were detected before starting the process. So before, I imagine this to implement in the firmware like a detection phase where we check how many cells are connected to this board, because you can use this with 4 cells, 2 cells, or use all 16 cells. And if we detect voltage on 4 cells, that's going to be the workflow that's going to be created to check that battery, store that capacity for each cell, and then move to the next one. And after all the cells are completed, it's going to generate, it's going to show the report on the Mega CNC Still have to implement that and figure things out, but I'm waiting for the boards to arrive. So the reason I created this before working on the new features of the software is because I need this board to test when I start developing more software features. Otherwise, I will give myself more work, and getting back to the software, adding more tables that are needed to add this, make modification to the firmware and all that. So I prefer to have the entire picture before I start developing new things on the software and on the firmware as well. So some of you were saying, oh, well, you should finish what you started on before working on new things. And I agree with that. I will not be doing crazy things with new accessories or new features that will take a long time, but this took like 2 or 3 days to complete, and also I think the software will be no longer than 1 day to implement a workflow that will loop through through these cells and perform the capacity test on it. So you will be able to install up to 7 boards on the Megacell Charger Pro. That's a limitation. Technically, you should be able to add 8 of these because you can combine the addresses. S1 is a switch to change the address for this IC right here. That's going to control all these MOSFETs to connect or disconnect the cells from the pack. And one of the addresses is already used in the Megacell Charger Pro, and that's why you can use up to 7 devices. But I think that's more than enough for most of the users, because you will be able to combine slots, then connect to this board with the output port. So on the output of this board, you're going to connect an accessory cable that goes through the Megacell Charger slot. So it can be one slot or a combined slot, a group of slots, 2, 4, or whatever number you want to have. That will depend on the capacity of those series that you're testing. So if it's just regular cells, 3000 milliamps, and you get a total of 6000 milliamps, you can get away with one slot, or you can combine it to have up to 4 amp discharge rate, and get 2 slots combined with this board. So right here you're going to have the J2 and J3 connection pins. That should take in the balancing leads, and it might require some some adapters as well, because right here we have the minus. This one should work with default, but on the second one we need the minus from cell 8. I will have to check how those are linked usually, but I think it's not. But I think it's going with the 9 through 15. But I think it's going with the 9 through 16 here. But I connected it this way so you can plug it in either ports, and it should still work without any problems. So maybe you will have to offset this, and you see that the pin 8 is already connected with this one. So you can just move it up, or maybe in the next version I start with 9 and leave this one So yeah, if you have a 16 cells, you might have to offset this one with one pin and leave pin minus right here unconnected, because I already have it from J2. So that's basically it for this. Let's check how's the Raspberry Pi image going. It's 16%. So it's made on a 4-layer PCB because I wanted to have enough room to drive the traces. So let's get into this one a bit. So on layer 2, I duplicated the traces from the bottom layer as well, to have some thicker traces to minimize the voltage drop due to the circuit. You'll still have a bottleneck on discharge rate because of the balancing leads. You can use like 0.75 millimeter square wires on these connectors, or it could go up to 1 millimeter, I think. It still gives you a limited current draw from those cells, but the point is not to test the pack fast. It's more like a diagnosing tool for those packs where you want to find if all the cells have similar capacities, or rebalance the pack. So it will store charge it to the voltage that you set in the Mega CNC, and that will balance the entire pack. But I think it's going to be helpful to see that all the cells have similar capacities, and if that's not happening, you will know which cell needs to be replaced. So instead of cutting all the connections for that pack, you just strip down that cell with lower capacity and replace it with another group of cells with the capacity matching the rest of the cells, and also the internal resistance. So I think it's going to speed up repairing some of the packs. And it will add an extra benefit of using the Megacell charger. This board could actually work with the old version of the Megacell charger as well. And because now I have developed the firmware to match the new version, I might be able to implement it. But instead of connecting it with the cables on the Megacell Charger Pro, I have similar J1 connections right here. So these JST connections will go with a wire like so. You get it from the back of the board and provide direct power to this. With the older version, that connector is not present, and you might have to solder some wires for the I2C connections, and also get 5 volts delivered to this board. I will probably do this mode and show you how to connect this board in the future. But first I will be implementing this for the Megacell Charger Pro because it's easier for me to test. And after that we'll move to the older version and provide you with the solution to add the connectivity required for this board. So on the output there's going to be a XT30 connections. That will be similar to the connection for the board I used to discharge cells by charging other cells. I still have to make a video for that. Probably I will do it when I test this board as well, because that will make an interesting project to have the Megacell charger discharging a pack while charging some other cells like lithium phosphate, 280 amps maybe, some cells like that, or we can put more in parallel, and that will give you some of the power back instead of wasting it through heat. And also that will solve the issue of overheating by discharging with 3 amp on the hobby version, because right now it's you should not pass 2 amps on the hobby version for discharging, because you will see the LEDs blinking that the board is overheating. On the Megacell Charger Pro Commercial, that's not a problem, because I have a total of 4 fans installed, and that provides the cooling required for 3 amps discharging. But to avoid overheating those small modules, let me show them on the website actually to know what I'm talking about. So let's go to hardware, accessories. So this one right here, and this one is cool for other projects as well, because you have the input right here, which is the input you get from the discharging MOSFETs from the Megacell Charger. So this mod will work like you remove all the resistors from a cell, from a slot. You remove those resistors, solder 2 wires, plus and minus, that you get from there, and you connect them to the input of this board. This small switch right here lets you pick which output voltage you get, so it can charge 4.2 volt cells or 3.6, which is 3.65, I think it's set for lithium phosphate. So this switch will allow you to regulate the output voltage, and yeah, that's going to limit the current to up to 3 amps. But on the Megacell Charger Pro, you also have the ability to set the current for discharging per each slot, so that it doesn't matter that this board can draw up to 3 amps. The Megacell Charger Pro will set it to 500 milliamps, for example. So installing this load on a slot combined with this new accessory will give an interesting device to use for testing large packs without wasting that much energy. So that's about it for this board. Let's get back to our Raspberry Pi. So the image was written, and now it's verifying it. You can let it verify it, and it will give you an OK, or let's cancel it for now. Right, so once you get the SD card, let me get my Raspberry Pi from the kit. Right, so you have the SD card and the Raspberry Pi. Plug it in the back right here, like so. And then you need an adapter, which is for Raspberry Pi. Can deliver up to 3 amps. If you use a low power adapter, that's going to give you some issues like low power when running the Raspberry Pi. So I chose to use one that's rated at 3 amps, and that will work just fine. It's nice that it comes with all these adapters right here, so we can ship all over the world without having issues with power adapters. So I plug this one. It has this USB-C connector right here. I plug this one and connect my Ethernet cable. Okay, it's going to take like 2 or 3 minutes to boot up, and after that I should be able to see it in my router. So let's go to the router page. Alright, so this is it right here. RPi MCC 1.45. Let's see if it already booted up or not. It did not start the the service yet because it needs to fully boot up. It requested an IP, so this should be IP address. And I want to also check in the meanwhile if the SSH updated with the new settings. If there's a new version on GitHub, you log in with SSH into your Raspberry Pi. And if you list the MCC, and if you list the files, you're going to see the MCC service update. So we can run this file like so. And that will run all the commands that are required to do the update. In case there are changes to the database, you can also restart the application because it will restart the service after this completes. It will restart the Mega CNC, but you also have to reboot it after the changes are applied to the database. So yeah, it's running all the build commands and all that. It's going to take like 5 to 10 minutes. I'm going to let you run this command and see it for yourself, how it works. And here it is. This is the dashboard. Still have to implement these total cells and good cells, total projects. This is some placeholder right here. Disregard that for now, please. To add a new project, you go right here, get the project, and to add a device. I don't have any devices connected, but you add the IP address, scan the device, add it to the project that you created, and that's all. For the settings, you can download the QZ tray to install the software required to connect to your printer. And this QZ tray should be installed on the machine where you access the Raspberry Pi from. So you don't have to install it on the Ubuntu machine or on the Raspberry Pi. It needs to sit on the Windows machine. Most of the people will have their printers connected to their Windows machine to print documents and all that. So install QZ, configure your printer, and then connect to it. Search for the printer you want, and it will get connected. And I also encourage you to watch my other video where I go more in depth on how to use the Mega CNC application, how to get the printer set up, and how to connect to it. And you will see how to print the labels and what configurations you will see on the next page as well. So that's it for installing the Raspberry Pi 4 image on SD card and start enjoying the Mega CNC application without having to install everything yourself, like the Ubuntu and also all the prerequisites that are required to build this project. If you want to configure your own, you go to Mega CNC on GitHub, and you have all the information required to build this. I know that some of you would like to run this app on Windows machine. I looked into that. I installed Docker on my Windows, but it's not as good as it is on Ubuntu. And for this reason, I stopped looking into that. And I know that having a Raspberry Pi is maybe an additional cost to this. It will save you on the long run, in the first place on electricity, because this device doesn't consume a lot of power to be kept in place, and also it will gather all the data from your Megacell chargers while they are running. So you're free to reboot your PC as many times you want. You can leave it off during the testing procedures and starting up again when you come back to work the other day, and have just the Raspberry Pi being on will save you on electricity. This started to be less and less expensive. So yeah, I think it's a good solution. We're offering it pre-configured, but for those that have access to Raspberry Pi, feel free to buy it yourself and use the SD card image to write it. So thank you very much for watching, guys. If you have any questions, don't hesitate to ask. You can get connected with me on deepcyclepower.com using the chat features or the contact form, and I'm going to reply as soon as possible to your questions. And have a great day, guys, and let me know what's your feedback on using the Mega CNC. Have a great day. All the best.